So question 9, we want to graph a logarithmic function that's given. We want to select a function for each graph with these options here. So remember, our parent function is going to be y equals the log of x base 7. Now remember, for a log function, instead of having a y-intercept, it's actually going to have an x-intercept. So 1, 0 is going to be the x-intercept. Instead of having a horizontal asymptote, it's going to have a vertical asymptote, which is going to be at x equals 0. So those are the main two characteristics to this function. So if I hit y equals, if I come across here and change that to a 7 and take the 5 out of there, all right, we'll just make that, just put an x there and see if that takes it. So if we graph that, so notice how this is going to be the graph of the parent function. So it's going to look like this. Here's the x-axis and y-axis. There's this 1, 0 here. So the graph, I'm going to go ahead and just draw it in purple. The graph kind of runs that way and then kind of starts to approach the y-axis. So it has a vertical asymptote. So that's our parent function. So if you look at the table, notice how there's nothing to the left of the y-axis. So you can't have x being 0 or -1, so forth. 1, 0 is an easy point to identify, but notice how the rest of them are like decimals, but notice how 7, 1 is also an identifiable ordered pair. So let's see if we can actually find this function here among the functions. So notice that the second one here is our parent function. So we're just looking for that graph right there. That looks like this one right here. So that looks like y equals, we'll do that in green. So y equals the log of x base 7. So that's our parent function. So I like to kind of look the ones that move things around first. This one here looks like an easy one to do. Notice how there's this x minus 1 on the inside. So it should be the same graph, except it should be moved. So since I'm thinking backwards, it should be moving right. So that should be like, instead of being at 1, 0, it should be at 2, 0. So I'm looking for this graph here, but passing at 2, 0. That looks like that one's what that one's doing right there. So that looks like that's going to be the y equals the log of x minus 1 base 7. If I want to double check myself, I can type in y equals, and we can kind of delete there, put x minus 1. That looks correct. If I hit graph, notice how that slides over to 2, 0. So that notice the rest of the graph really isn't shown very well, but it's just kind of going down close to the y-axis. So that one's out of the way. This one here also looks pretty easy to do as well. Notice how the minus 1 this time is on the outside. Since it's on the outside, that means it's actually going to move vertically down 1. So it's going to be this graph, but instead of being at 1, 0, it's now going to be at 1, -1. So I'm looking for that 1, -1 spot. This one looks like it's doing just that. So we're going to have y equals the log of x base 7 minus 1 would be that graph. From there, looks like the rest of them start to have these negatives. This one here looks like the easiest one to do because the negative's on the outside. If the negative's on the outside, that means we have a reflection over the x-axis. So that's going to be over the x-axis. So it's going to be this graph, but instead of pointing down, it's now going to be pointing up, and it's going to be going underneath as well. So this top part's now going to go underneath, and this bottom part's now going to go up towards the y-axis that way. So I'm looking for a graph that kind of does the same thing, but in opposite direction. So this one here looks pretty close. No, it's got to be a reflection. This one here looks best. So notice how it's been reflected over the x-axis. So that's going to be y equals the negative log of x base 7. If I want to double check myself, I could type in y equals. I have to clear it off this time. So if I hit the math button, go up arrow, I can now type in the 7 again. Oops, I need a negative first, so don't I? I still need that negative first. So let's see if I can insert a negative there. Yeah, that did it. Okay, let's see if we hit the graph now. So that's how it is. Kind of mirrors that number 7, that 70 there, this one here. So we got that one out of the way. So it looks like the next one to be able to do would be this one, because notice how there's a negative on the inside. That's going to reflect it over the y-axis. So this is going to be over the y-axis. So this graph here is now going to be, instead of pointing to the right, it's going to be pointing to the left. So it's going to be kind of running in this direction here. So I'm looking for that. So I'm looking for that. It looks like this one looks pretty good because there's the y-axis. It looks like it's pointing the other direction. So it looks like we have y equals the log of negative x base 7. It looks like that graph. So if I can see, take this negative out here and see if I can insert a negative on the inside. Yeah. So the graph, notice how it does kind of mirror this graph here. So we got that one out of the way. So next thing I'm looking at is maybe this one over here. So notice how this is a reflection twice. So what I'm going to basically do is I'm going to look at this graph right here, the log of negative log of x base 7. So it's going to be this graph here, but it's going to be reflected also across the y-axis. So this is going to have two reflections over the x-axis because of the negative on the outside, and over the y-axis because of the negative on the inside. So this graph here, instead of pointing to the right, it should now point to the left. So I'm looking for this graph just pointing in the other direction. So it looks like this graph here does just that. So that should be y equals the negative log of negative x base 7. So that's that one. So now we're down to this one and this one. To me, this one looks the easiest because that 1 means the graph should move up, but I'm looking at the negative log of x base 7. So I'm looking at negative log of x base 7. That's this graph here. So I'm looking at this graph here, but it's got to be shifted up 1. So instead of being at 1, 0, it should be at 1, 1, this graph here. So I'm seeing this graph, and that's how it's now going to be moved up to 1, 1. So that's going to be that graph there. So that's going to be y equals 1 minus the log of x base 7. So then we have like the log of 1 minus x. So notice how there's this negative x inside here. But the catch is, what this really should look like is y equals the log of, I should put a negative on the outside, and this should be like x minus 1 base 7. So notice how there's really a minus 1 inside here, so it really should move to the right one. So what we're looking for is that graph moving to the right one. So see if we can see that anywhere. It should be this one here. Let's see if we can kind of double check it here. So y equals clear. So math, and put a 7 there, and then a 1 minus x. See if it kind of mirrors what we're thinking. So it looks like it's crossing at the origin, and then and there's the y-axis here. Notice that it is crossing at the origin. So that looks like it's supposed to. So actually that should be, that actually went left 1. think I need to do some thinking on that, but we have y equals the log of 1 minus x inside there. So we should be seeing two things. So I guess that reflection, so it was over here at, because the reflection, so where's the graph negative x at? So notice how the negative, it was at negative 1, 0. So it was moved to the right one, and it's now at 0, 0. So it's this graph shifted to the right one. So that does make sense that that's what we got there. So notice when you do this, you kind of have to just kind of work your way through those. I like to do the shifts before first, and then I look at the reflections, and then we look at the ones with the shifts and reflections last.